From what we have learned so far, whenever we would like to investigate the motion of an object, what we do is identify all the forces or the external forces acting on the object, draw a free body diagram, and then use Newton's second law of motion to either find acceleration or forces or whatever. From there, we learned the work energy theorem, which says that the sum of all works, or the net work acting on an object, is the change in kinetic energy of the object. After that, that led us to the conservation of mechanical energy, which says the change in kinetic energy plus the change in potential energy of an object is equal to 0. Energy is conserved. Mechanical energy is conserved. Now, of course, if we have lossy forces or external forces, this will change like we had previously. Change in kinetic energy plus change in potential energy is equal to the work due to the external forces. Recently, we talked of momentum and impulse, which says the sum of all impulses is equal to the change in momentum. Or if we don't have any impulses or no external forces per se, change in momentum is equal to 0. Or momentum initial is equal to momentum final. Now, other things that we have learned so far, displacement, for example, we can use x for displacement or d. Remember, it's a vector. And then when we have rotation, we use theta. For velocity, we use v. It can be vx, vy, whatever. And then omega for rotational motion. I'm adding the arrows here because they are vectors. And for acceleration, it's a or alpha. Now, for inertia, we use mass in the study of regular motion. For rotational motion, we use the rotational inertia, or what's also called as moment of inertia. Other things that we have learned: kinetic energy is given by 1/2 of mv squared. Kinetic energy, the energy of motion. Newton's second law says the sum of all external forces is equal to ma. And then we have learned that the momentum is mass times velocity. These are the quantities that we have learned in the past.